Hey, good day everyone. I am Lawrence A. Abuhon, and this day I will simulate the fluid pressure using the Phet simulation. So in Phet simulation, we have so many fields to explore. So we can choose if we want biology, chemistry, earth science, mathematics, physics, and many more. So on this video, I will only choose physics, specifically the under pressure or the fluid pressure. So we will start by defining what is pressure. So what is pressure? So pressure is defined as the amount of force per unit of area. So we can have the formula P is equals force over area. But in fluid pressure, the equation is P or pressure equals density times the acceleration due to gravity times the depth below the liquid. So for us to have the total pressure, we have to add or to sum up the atmosphere pressure plus the pressure from the liquid. Remember that the pressure from the sea level or the atmosphere is 101.325 kilopascals. So let's start. So we have here the ruler for us to measure the depth of the fluid. We have the grid for us to easily measure how deep the fluid is. We also have the atmosphere in which we can turn in on and off. So we can also choose what units we can use if it is English or atmospheres or the metric. So on this video we will only use metric for us to have a uniform measurements or units. So we can also adjust the fluid density by clicking these arrows. So let's set it 1000 kilometer or kilograms per meter cubic meter. Okay. We can also adjust the gravity. So let's use the Earth's gravity, which is 9.8 meter per second square. So we can use these buttons to fill and to remove fluid or water. Okay, let's start. So let us first remove the water. So we can use this in order for us um, to measure the pressure. So let's fill it. So we're gonna put it here. So at this juncture, the pressure is 101.361 kilopascals. So let's put water. So as you can see, as the water rises, the pressure also increases. So let's use the grid in order for us to determine its depth. So, okay, let's measure the pressure on every depth. Okay, okay, at this moment, the total pressure at the depth of 3 meters is 130.286 kilopascals, and at the depth of 2 meters, the pressure is 121.8 777 kilopascals, and at 1 meter depth, the pressure is 101.550 kilopascals, and at the surface is the pressure from sea level, which is 101.325 kilopascals. So at this, now we can conclude that the depth have its participation on the fluid pressure, which means that the depth is directly proportional to the fluid pressure. This means that the fluid pressure increases as the depth increases, or as the depth increases, the fluid pressure also increases. So right now we are seeing the total pressure uh, as the combination of atmospheric pressure and the fluid pressure. But if we are going to turn off the atmosphere, we can see the decrease in pressure. So this means that the atmosphere also plays uh, a great factor on the pressure. Let's turn it on. Okay, so let us adjust the fluid density in order for us to see if there is changes when we are trying to adjust the density. So let's think of the fluid as the honey. So let's see if its density will affect its pressure, its fluid pressure. So at the depth of 2 meters, the fluid pressure of the honey is 129.517 kilopascals, while at the depth of 1 meter, its fluid pressure is 115.954 kilopascals. So there is changes when the fluid density changes. So let's set it back to water. So we can conclude that density also plays an important role in determining its fluid pressure. So we can say that as the density increases, or the fluid density increases, the fluid pressure also increases. So let's adjust the gravity from um, from Earth to Jupiter, which is 24.9 meter per second square. So we can see here that as the depth or as the gravity increases, the fluid pressure also increases because the fluid pressure is the density times acceleration due to gravity times the depth below the liquid. So let's proceed to this second scenario. So let's put it here. So let's find out if there were changes if the area of the fluid uh, changes. Okay. Okay. Okay, let's use the ruler. Okay, so let's put that here. 114.120 kilopascals. Also let's put that one here also. Okay. Then, okay. So let's try to find out if exerting weights will affect its fluid pressure. So let's put a 250 kilogram object here. So let's see if the pressure increases or decreases, or let's see if it would not affect the pressure. So there's a sudden or there's a small changes on the pressure. Okay, let's put a 500 kilogram object. Okay, so it is clear that as we exert force or weight on the fluid, its pressure, its fluid pressure increases because it compacts the water molecules, which creates a larger pressure. Okay, uh, that's all. That is all for today. Okay, thank you for watching.